Hello, everyone. I'm Angelique McAvoy, Executive Officer of the Society of Precision Agriculture Australia. Welcome to today's webinar, Unlocking Automation, Connectivity and Boundary Establishment. This session is part of the education extension of Grain Automate, a GRDC initiative on behalf of Australian grain growers, aimed at accelerating the adoption of machine automation, autonomy and digital technologies. In the spirit of reconciliation, we acknowledge the traditional custodians of country throughout Australia and their continuing connections to land, sea, and community. We pay our respects to elders past and present and extend that respect to all Aboriginal and Torres Strait Islander peoples today. By 2028, the goal of Grain Automate is for close to 80% of growers to have the knowledge, understanding, and capabilities to successfully integrate autonomous field-based machinery into their farming systems and businesses. Today's webinar is the second in a series of online events bringing together growers, grower groups, agronomists, researchers, consultants, students, and suppliers. In the session, we'll explore how aligning agronomy with precision technologies such as variable rate application and reliable connectivity can drive greater efficiency through automation on farm. We'll also look at some of the challenges around connectivity and boundary establishment. Thank you to GRDC for their collaboration with the Grain Automate initiative. I'd also like to acknowledge Bindi Isbister from Agrarian Management, Tom Andrews from Connected Farms, and West Australian grower Tom Longmire, and South Australian grower James Venning. Thank you for your time, expertise, and commitment to advancing ag practices here in Australia. And finally, a big thank you to our technology partner, ORM, for hosting today's webinar. Please note that the session will be recorded and will be available on the GRDC and SPA websites. Thanks for joining us today. We're excited to share a session packed with insights and inspiration that will hopefully spark some new ideas and fuel your next steps to automation. Thank you.
Thank you, Angelique. Hello and welcome. I'm Matt McCarthy from ORM, and it is my pleasure to host this Society of Precision Agriculture Australia event on unlocking automation, connectivity and boundary establishment. During today's presentations, you are invited to join the conversation using the chat feature. Today's program has time allocated for questions and discussion, so please take the opportunity to be involved. Now, before I introduce our first presenter, we are going to launch an audience poll. So please take a moment to complete this poll about farm automation, and we will revisit the results a little later in the program. Our first presenter today is Bindi Isbister, who works as a precision agriculture consultant with Agrarian Management based in Geraldton, Western Australia, and has more than 20 years' experience in agricultural research, development and extension, specialising in soil management, controlled traffic and precision agriculture in broadacre farming systems. Welcome, Bindi, and I'll hand over to you now to start us off today.
Thanks, Matt. Hello, everyone. After the last 4 months of data processing and creating prescriptions, I think my best form of advice when adopting autonomous systems is to set up their digital farm. So that means get that grower, farm, field consistent and your boundaries, because not only is it going to improve your machinery operational efficiency, it's also going to save you a lot of time trying to find data files hidden in obscure places or reprocessing data because you've got it in the wrong boundaries. My name is Bindi Isbister. I'm a precision ag consultant with Agrarian Management based in Geraldton. Today I'm going to share with you some tips on aligning agronomy with technology, in particular around variable rate setup and on-farm trials. And I'm saying tips because with precision ag, the devil is in the detail, and I've only got 10 minutes. So I'm hoping, if anything, this will either inspire you to ask our panellists a couple of questions. Perhaps you'll come along to a Grain Automate workshop over the next year or two, or you'll go home and ask the significant others in your farm business some specific questions around adopting this technology. So why is setting up that digital farm really important? Well, it's about organising the filing system. So as we move to autonomous systems, we're starting to transfer data between different platforms. And it's much easier if we've got everything, our paddocks labelled the same, and we use consistent products, and all our boundaries are consistent. So for example, if we have a look at this here, we've got the machinery software platform that everyone will have now. It might be John Deere, could be our CNH Field Ops, and that helps manage our machinery and our application of inputs. And then we'll also have some kind of farm management software, or maybe you've still got the old pen and paper and a filing system, but that's like where you record all your agronomy and information about what happens on the farm. And then now we'll tend to have in the middle, we might have some specialised precision ag software that can help you analyse your data and create application maps. And in this system where we're moving it between the three platforms, you can see all the different boundaries here. It becomes essential that we have the same names and paddock boundaries. And as a tip for those of you in ag world, apparently the ag world boundaries are it. So everything gets based on them. So I recommend when you're setting up ag world to actually use your machinery boundaries from your software and then transfer those into all of the other software platforms. So the most common form of or autonomy, I guess, that we're all familiar with in precision ag is variable rate technology. And it's been around for the last 20 years and the principles are still the same. It's just that it's starting to get easier because our machinery's coming variable rate ready, or we think it is. So this is actually the process of the variable rate cycle, and there's 7 sort of processes. And I guess the most important one is, in my mind, what is that target management issue? So I found in my experience, if you need to have that targeted management issue, because that's then going to help you decide what kind of information you need and what kind of processes you're going to implement. So it might be managing fertiliser, it might be improving your gross margins across different areas of the paddock, it might be targeting weeds, or whatever it is. Choose that management issue and then you're actually going to have a vested interest in getting this technology to work on farm. So the other steps are measure and map the variability. So that's about collecting and analysing the data. We then can move through, if we're talking variable rate, creating a prescription map to allocate the inputs to the zones. So that's your decisions and agronomy, connecting the two together. Then we need to load it into the monitor and get it working in the paddock. So that's about setting up your machinery. Then ideally we want to record what we've actually done in the paddock and download that application data so we have that record of what's happened. Then we can have a look and analyse it and measure the response. Perhaps that's with yield data or some visual observations in the paddock. And then we check it and refine it and we go again. So variable rate's not a set and forget kind of thing. It's important that you actually review your strategies as you go along, and it does develop as we get new technologies and new information. So with every process, there is tasks, and Emma Leonard in the last one spoke about moving to autonomy. It's a good idea to map the actual process so you then get to identify what resources and information that you need. And I think just the machinery one's particularly important because that includes getting the machinery set up to get it ready, moving data in and out of the machine, and then also thinking about your products and how you apply it on farm. I have had one farmer that we went through targeting a management issue. We developed some prescription maps and zones, and then he got to it and he said, oh, actually, my farming system's not set up for this because I apply all my NPK up front, and I actually don't want to vary drop the K on the sands, which is lower yielding. Therefore, for me to actually adopt this, I'm going to have to change my application strategies and the products I use. So again, it's think about that key management issue and then choose the data that'll work for you. In terms of data, there's so many different options, and this is probably my devil in the detail, and you can explore this on your own, but we've got so much data available to us now, from yield data, protein data, satellite imagery, electromagnetics, gamma data, and it's all about picking layers that will help represent the variability or that target management issue that you've got. All data that needs ground truthing, and that could be in the form of soil testing or paddock experience, so your own working knowledge of the farm. I think that's really important when we're looking using data layers is actually including some of that knowledge. So in this case, we've used that data to zone up to different soil types, and then we can then go on to set up what how we're going to manage that agronomically. So in this case, it was looking at different fertiliser rates. So if we focus on this management issue, which is quite common in our region over here in northern WA and Geraldton, we're into matching inputs to soil type and yield potential, because our biggest yield variation is based on soil type, and we might have varying degrees of sand or loams, and they have different yield potentials associated with us. So in this instance, we've got our regular soil testing program that we do across the paddock. We've got some data. This is yield data. This not only has been used to zone up this paddock in combination with the EM and Gamma, but it also helps as a check and validate and measure, I guess, our activities for the year. And we've developed these management zones, which in this case are to soil type. So we've got 5 different soil types: a clay, a yellow loam, a deep ripped yellow loam, a heavy red loam, and a shallow gravel. So when we come to making that agronomic decision, it's about matching our inputs. So we've got the yield ranges for the different zones, and then we match our products and nutrient requirements based on our soil types. So it's really the same as what we would do on a large scale. It's just that instead of making one recommendation, the agronomist makes multiple recommendations in one paddock. And in this case, we then variable rate all the different operations on the farm. However, I will say that in the first year, I do recommend you just start with one input to vary and make sure that you get that right. And generally, we find that something like potash, where you've got sand and red loams, is an easy win, and it's out of the spreader, so you can see the rate changing as you go, so you have confidence that the tech's actually working. The other part of variable rate is the opportunity, is actually testing and validating our strategy, or you can actually use the technology to test anything, any new agronomy practice that you'd like to on the farm. And a few tips, I guess, for on-farm trials is to keep it simple. Use 1 or 2 treatments, replicate where possible. Over here on the right, you can see this map where we tended to just do 3 different strips across the paddock, 1 rate. But what we find is there's actually this can be underlying variability in different soil types. Therefore, just doing an average yield of those treatments isn't going to be so valuable. So I would then clip out the data to the different soil types and actually analyse the response over those soil types. Now, if you're doing trials, also you need to make sure that the plots are at least 2 header strips wide and a minimum of 100 metres, maybe 150 metres long, particularly if you're using variable rate technology, because that's how long the product will take to actually change through the system. And ideally use 1 header to harvest the trial. And that's easier said than done because of the scale of our operations now and how we work. So that's really just to make sure that the calibration's the same, or if you're going to use multiple headers, actually work them together. But ideally one header to work the trial. And I guess the other thing that becomes more important with autonomous systems as we're starting to apply variable rate technology automatically, and the opportunity with trials is if you set up a prescription, the machine will actually just do it, and you don't have to go out there with a peg or move it around, is to actually confirm that the treatment went out. So many times I think we've done trials and found that things actually haven't been applied in the right place where we thought it was, or it was a different rate. So I really strongly recommend actually using the application data and remembering to tick on in your screen that you're saving the application data. This is one example of a trial that we did. That was a phosphorus response trial. We had 4 different rates of fertiliser. We had 2 replicates on 2 different soil types. So one in the south of the paddock and one in the north. This is the NDVI in July, and we could actually see that there was a treatment response here, clearly in the NDVI, but things looked a bit messy up in the north, which I thought, well, we better go and have a look at the application data, like what actually went out here, and then is it a seasonal influence or is it actually that something went wrong? When we had a look at the as applied map, it actually looked really ugly. And this is becoming an increasing problem, I think, with trials where we're setting them up variable rate, like from the paddock and moving, sending it to the machine, where we've got different correctional signals and using different geo-reference systems. So we're starting to find that the run lines don't quite align. And this is the problem that's happened here. So you can see these jagged edges in some of it where the machines kind of got confused because it wasn't quite on the run line. So you can actually tick something on in the screen that makes sure that it chooses the most common rate, and that will help evolve that. So if we zoom in and have a look, you can see here that the AB lines actually didn't quite match. So down the bottom is my plan that we did in PCT. The blue lines are the swath widths for the seeder. It's 18 metres and the plots are 36 metres. And I think like in CTF where we've got a 12 metre, 18 metre, 12 metre header, 18 metre seeder and a 36 metre boom spray, it's becoming quite complicated, a little bit more complicated. You have to think about it a little bit more about where you're going to put the strips in the paddock. And if all else fails, go and hang a peg or put a drum in the paddock. So go back to old school. So my tips, set up the digital farm, choose that management issue, and that'll help you choose the data. Use on-farm trials to test or benchmark your variable rate strategies. A lot of times I've had people come and say, oh, I used variable rate last year. Can you measure the benefit for me? And I'm like, well, have you put in a trial strip? No. I was like, well, it's quite hard then. We can go back and we can have a look at the average yield and gross margins over the different zones. But if you actually don't have a different treatment in that zone, it's really hard to benchmark if we actually got an economic benefit. And the last one is that precision ag takes patience and perseverance. And my husband might call it stubbornness, but I do recommend if you're going down this track to start early, make sure it's set up before things get busy, particularly at seeding or if the rain's coming and you're going to be putting out fertiliser, because nobody likes to stop for technology if it doesn't work properly. So thank you very much. This I am working with SPA on a Grain Automate project, and we'll be running a series of workshops here and across the country with other consultants and groups around the country on variable rate technology and adopting autonomous systems. So look out for those coming up in the next 12 months.
Indeed. Thank you. Indeed, watch out for them coming up in the next 12 months. Thanks very much, Bindi, for providing such a sharp overview of aligning our agronomy and with our technology. Bindi will be joining us for the panel session a little later, so please send through any questions you have that you'd like Bindi to address. We will now welcome our next presenter, Sue Madalena from Connected Farms, who has stepped in for Tom Andrews today. Sue joined the Connected Farms team after 20 years with the Commonwealth Agricultural Department as an industrial chemist, specifically looking into chemical residue monitoring for export markets. She is delighted to be involved in the Connected Farms Grain Automate project, enabling on-farm improvements through connectivity. Thank you for joining us today, Sue, and over to you.
Thanks, Matt. Good afternoon, everyone. Let's talk about what is the right kind of connectivity for automation. We all know what the problem is. Around 67% of Australian farmland does not have signal quality suitable for autonomous agricultural practices. And while it's an extreme example, this photo shows what is common, that farmers know where on their land they have connectivity and where they don't. This patchy salt and pepper nature of signal is not suitable for automation, where machines need to be connected 100% of the time when they are operating. It's also important to differentiate between mobile or smartphone connectivity to make a voice call and send text messages, compared to the mobile broadband data connectivity that is required to enable automation and robotics. So meet Uniform 2, a swarm farm robot that, unlike Mike in the previous photo on the roof, can't go to where it knows there is signal. It diligently must travel on its mapped path up and down the paddocks. Uniform 2, as shown here, operates on Willaroo, a Warrakiri cropping farm near Goondiwindi on the New South Wales-Queensland border. Willaroo serves as a robust example of a corporate mechanised cropping operation of substantial size, varied terrain with a well-defined layout. Notably, approximately 85% of Willaroo lacks existing connectivity from the mobile networks Telstra, Optus or Vodafone. When we began with Willaroo, the farm had only areas of sporadic and patchy coverage at best. The Swarm Farm robot sprayer's use is restricted to areas of the farm that have coverage. Due to Connected Farms' work with GRDC's Grain Automate project, the connectivity for Uniform 2 was first lifted to 85% using our dynamic SIM technology, and with the addition of a managed and secure Starlink Mini solution, that connectivity has now been taken to 100% coverage for the Swarm bot. And now we have connectivity for automation. This connectivity has increased the robot's area of operation and hence usage, and has also increased the farmer's confidence in its use. Connectivity in the form of mobile networks do not cover farmland. To demonstrate the gaps in connectivity, this is the cropping areas of Western Australia, overlaid with a map of Telstra coverage. Note the clustering around population centres and along highways. The mobile operators' business models are all population-based, so their networks are aimed at towns and along highways and are not providing place-based geographic coverage. They are leaving the tasks of covering farms fence to fence to specialised providers like us at Connected Farms. Recently, a senior Telstra executive described their coverage over farms as fortuitous at best, confirming that connectivity for farms is not on their agenda. And this is what we can achieve with just our SIM technology with careful antenna choices in our base comms extend solutions. Our dynamic SIMs utilise the strongest cellular signal available from the multiple mobile network operators, and when inserted into a device like our comms extend, will detect, connect, and utilise that strongest signal, converting it to robust Wi-Fi coverage, changing between signals with vehicle movement over farmland to always ensure that you are working with the strongest signal on offer. In time, voice and SMS connectivity will be served by direct-to-cell services from LEO satellites. But this is connectivity for low packet data and will not be suitable for connecting machines and automation. They need larger antenna size with higher input power. Full connectivity is a prerequisite to automation for us. That was a quote by Yami Hinman of John Deere. Autonomy needs connection 100% of the time, essentially so that the robot or autonomous machine can connect with the human when things are not going well. For instance, if a machine detects an obstacle in front of it, it will halt, send a message, often with visual imaging, to a remote operator for a go or a no-go decision, or to advise that it's getting low on fuel or spray chemicals. Because connectivity to and from field machines is precious, it is best to divide data into what is data needed in real time and what is data for later. So data needed to operate the machine and, for example, work in section control is data needed in real time, compared to that data which is not needed to drive actions straight away, like image data from onboard cameras used for scouting purposes. This data is data for later and may be stored on machine and transferred later by a high-speed mass data transfer using very localised 5G bubbles at perhaps fuel points. We also need to be aware of where our data is generated and used. This will affect the connectivity solution required. For example, in an orchard or a vineyard where thick foliage or tree canopies exist, clear view of the sky is compromised, limiting the applicability of satellite-based solutions. At Willaroo, the SwarmBot's usage has increased with improved connectivity, showcasing the potential of connected technologies in agriculture. However, it's noted that the improved connectivity did not just help automation and robotics alone. It raised the efficiency of the overall farm, and in particular, its existing precision farming practices. The initial phase of our Grain Automate project has demonstrated transformative improvements in farm efficiencies, primarily driven by enhanced connectivity. The participating farms have reported improved data accuracy and availability, facilitating better decision-making, enhanced remote monitoring and management capabilities, reducing the need for as many on-site interventions, and increased operational efficiency as connectivity allows for real-time adjustments and optimizations, streamlining current practices. Challenges like network shutdowns and traffic loadings highlight the need for resilient connectivity. So it's good to have options. Being able to rely on multiple connectivity inputs means insurance on farms. The future of agricultural autonomy and agrobotics is driven by robust, resilient connectivity where and when it is needed. So solid planning with experts with a view to future-proofing will never let you down. In some instances, it may be required to build private 4G or 5G networks, but this should be a last and not a first resort. It is predominantly where other technologies won't be suitable, as mentioned earlier, such as in orchards with dense canopies at times that block satellite signals, and in instances where there is no cellular signal to build on. The main takeaway message is that a proper review of connectivity should be undertaken before starting on an autonomous or robotic pathway. Not only will this ensure the maximum chance of success with any autonomy platform chosen, it will also bring efficiencies to your current farm practices and precision ag methods. Here are the contact details for Tom Andrews of Connected Farms, our CEO and connectivity guru, and my details also, should you need to reach out to us. Thank you.
Thank you, Sue, for those really interesting insights into such a hot topic as connectivity is. So thanks very much for that. We're now going to move into our panel session, but before I introduce the panel to you, let's have a quick look at the result of our earlier audience poll, which may help with the discussion. So the poll is showing up here. What process would you or your clients like to automate first? Highest on the list there is soil amelioration. Fallow pre-sowing and weed control is not far behind, 21%. Crop nutrition, 14% of our audience have listed that. And then following on down from there, 10% and down in-crop weed control, sowing and planting, in-crop pest control and harvesting. So that's our result of the first question on the audience poll. The second one was, at what scale are decisions tasks currently performed or advice delivered? So in the paddock scale, 45%, zones created from digital maps, about a quarter, farm and the whole of farm, 20%, and zones manually identified, 9%. So that gives us a little bit of background for our speakers, also our presenters, on where our audience is at and what they're thinking around this topic. So with that in mind, I would now like to welcome James Venning and Tom Longmire to join us for our panel discussion, and Bindi is going to rejoin us as well. But firstly, to introduce James Venning is a farmer at Butte in South Australia, and he uses a range of technologies to manage varying soil types with a focus on improving productivity, efficiency and cost effectiveness. Welcome, James.
Sorry, I had myself on mute. That's a bit of a fail, but yeah, thanks for having me.
Good. We can hear you now, James. Excellent. So, James, as a start off, what technology are you using on farm, and how do you know the tech is returning on your investment?
So using a bit of a range of stuff. So variable rate. We've got best thing about returning on investment with that is lentils here are a big cash crop. So anything we can do to improve agronomy over ranging soil types is where we get good return on investment. So lentils don't like sand. So yeah, if we can treat the sand far differently to what we treat the loams, that's where we get really good return. A few other technology solutions we're using is soil moisture probes, weather stations, protein machines. But yeah, so not too much high input, high cost stuff, because as soon as you start spending a lot of money, you've got to start getting a far bigger return. So you're much better off to spend less to get into something, and therefore the return is far easier to achieve.
Yep, fair enough. Thanks very much, James, and welcome. And then we'll go to Tom Longmire. Tom is a farmer in Beaumont, Western Australia, northeast of Esperance, and after completing a degree in farm management at Marcus Oldham College, he returned to play a key role in developing and adopting precision agriculture on the farm. This includes adopting a swarm bot in 2023 to explore autonomy in farming. So welcome, Tom.
Yeah, g'day. Yeah, some of the tech that we've adopted with a swarm bot, we've got a weed it, and last year we've set up a snail bait spreader, a mice bait spreader. We've also got, a weather and moisture probe network, and have been doing variable rate for 15 to 20 years. And we've also been focusing a lot on internal and external boundary steering of machinery for weed control, and not picking up any weeds off fence lines or anything like that, and improving the efficiency of training staff. Yep,
good. Thanks, Tom. Thanks for that background. And again, welcome to the discussion. So we are taking questions from the audience, so please have your questions in. We've got a number of them. The board's lighting up, so perhaps we'll go to the first one. Emma's asking what type of connectivity is required to run autonomous systems. Now that's a question that we may bring Sue back in for, potentially. Sue, Emma's asking what type of connectivity is required to run autonomous systems.
I guess, as I said in my presentation, you're really requiring robust, resilient connectivity that's available to the autonomous piece of equipment or robot 100% of the time that it's in operation.
Okay, as simple as that. Thank you. Thank you. I'll put a general question to the panel around advice. How important is good advice when moving from variable rate, for example, to more semi or full autonomy? And in your experience, where has that best advice come from for your business? So, James, if I could go to you for that one first.
Yeah, good advice is obviously important. It can save you a lot of headaches. And I think the best advice generally comes from other peers or someone that's already done it, like an independent person that's advising other people. You don't need to reinvent the wheel. You can normally find someone else that's done it or doing it, and just pick their brain because they've found all the problems, sorted them out, and then you can just adopt that.
Yep. Thanks, James. Tom, have you got some thoughts there?
Yeah, I agree completely with James there of that if you can find someone who's done the learning. I'm very big on, if I can avoid trying to figure the whole thing out myself, I will, and try learn the best tips and then start from that platform. From an advice with autonomy and variable rate, I personally, in our strategy, we haven't found them too interlinked. Our advice with our VR doesn't have anything to do with our autonomy and adopting a swarm bot. You don't need to have variable rate to be able to do a swarm bot or anything, but I've sort of with having the automation, I think there's more room to be able to do more variable rate with some applications that are cost effective with using the robot that I don't need to be out in the tractor for, where it doesn't sort of justify the machine. But I feel like there could be some benefits in the future. But yeah, a lot of the advice with autonomy at the moment, because it's quite new, a lot of it is sort of figuring it out yourself as well, and what you're trying to achieve. Like, what is your main problem that you want to solve on your farm? For us, it was weed control at harvest. On a coastal climate, we have a lot of self-sown germinates with storms, and our labour was maxed out at harvest. So the ability to have a robot going along behind headers 4 or 5 days after the crop's sort of been harvested, that was our main problem, where we felt we could solve an efficiency and productivity.
Thanks, Tom. You did touch on something that, Bindi, you might comment on. You mentioned, Bindi, about having a strategic approach to what you were trying to manage, what the issue was. Have you got some thoughts on this question about advice?
Yeah, I agree with James and Tom about like seeking advice from others that are doing it. I think one of the challenges with precision ag and technologies is it's wonderful when it works, and it's absolute time wasted when it doesn't. And often it's because we have a problem that nobody like has found before, because we're trying to get it to do something that we don't want. So I think having that network of people that you can call, and it might be, you know, from your local dealer to your grower to an agronomist. And I'm really lucky to have worked in this space since early 2000 and have that national network of people that goes right through to developers. And I think when you're choosing products, and every second person's coming in trying to sell you a new product at the moment that's going to do your prescriptions or things automatically. And I always look now at, you know, are they based in Australia, or what's the local contact? What backup support can you apply or find? Because manuals, they never tell you the specific information. They just tell you like a step, but they never actually tell you the nitty gritty bit that you need to make it to work. Often you're just clicking buttons trying to get it to work. So I think having a network, and don't be afraid to ring someone when it's not working is a good strategy before you throw it away and don't do anything with it.
Yep, great. Thank you. Thanks for that advice. We might go to this question, which is a bit more very hands-on, practical one. Paul asks, what does the user do if internet access or connectivity is lost during seeding or spraying, so mid-job? How have you managed that? Perhaps if I go to James. James, have you had this experience?
Because I'm not using autonomy, I'm not sure if it's autonomy based, like in terms of an autonomous machine, but yeah, so my machines generally don't require internet access because I'm not autonomous, but yeah, things like RTK obviously requires internet access, but yeah, you can, as long as you get it within 15 minutes or so of each other, you can keep running. So I'm probably not the best person to maybe pass on to Tom or something.
Yeah, sure. Yeah, Tom, you've had this experience, I imagine.
Yeah, yep. With the swarm bot, when it's spraying, if it has dropped out or I can't access, the robot will keep running without, you just can't sort of see where it is. Once you're within sort of 50 to 100 metres of the robot, it does have its own Wi-Fi network that you can drive and actually control it with what's downloaded on the robot. So there is ways to keep it moving or keep it productive. But in terms of, we haven't had the situation where I need to download a new plan or update something on the robot or new mapping or whatever that requires the internet to download. I haven't been in that situation yet where I've tried to do that and not had access to the internet. So yeah, that's sort of on that part of the autonomy, and with our general seeding and spraying, once it's downloaded into the screen, I guess there is always the backup of taking a USB there if we need to.
Mm-hmm. Yep. So I'll ask Bindi and Sue, or Bindi first, if you've got anything to add there.
No, yeah, I agree with what Tom and James have said, and I think like we had a cyclone in 2021 that took out all the communications network and power, and we had a really good rain, and everyone wanted to get seeding, and I guess that highlighted the fact that sending prescriptions through the telematics wasn't going to work. So yeah, we had to go back to the old USB and driving it out there. So I think you know, it's having that, being a little bit organised, having a backup plan, and at the end of the day, manual override, if you can't get it done, you're just going to go with your average rate and get it in, because that's what we get paid on, getting the crop up and the grain in the bin at the end of the year.
Yep. Okay, thank you. And Sue?
It's tough when that happens. I think everyone might have experienced that. I think that's exactly why it's important to have connectivity that can rely on multiple inputs. You know, being able to build on cellular signal when you have that, whichever carrier that's from, and also being able to use satellite solutions options as well. There's that multiple input providing you insurance, I guess, on the farms. And also being able to rely on your connectivity provider, the expert that, you know, you have faith in are able to get assistance from. Okay,
thank you. Thanks, Sue. So the next question we will go to there is again on connectivity. This one is how much is the typical outlay for improving connectivity in these areas that, I can't quite read that, are required to access reliable 4G? There it goes, I can see it now. How much is the typical outlay for improving connectivity in these areas that are not able to access reliable 4G? Would you like to have a go at that, Sue?
I'd have to say that every scenario is different and needs to be considered specifically on what its characteristics are. That's why it's always best to pitch a bespoke solution, having a look at what you've got to work with, where you are, what options you have, what you're actually wanting the connectivity to do, where and when. So there's not really one sort of answer to fit every approach, and you're going to get the best results if you have a customised solution.
Yep, fair enough, Sue. And one of the points I thought was great you made was, you know, doing that assessment early to understand where your what your service was like and where your pitfalls are. So that was certainly highlighted in your talk. So some other questions have come through. There's one here about variable rate, and it's about adoption of variable rate. Andrew asks, with most equipment sold over the last 15 to 10 years capable of variable rate application, what is the biggest obstacle that keeps growers from taking advantage of this technology? That's a question about adoption. Who would like to have a stab at that, James?
Yeah, so I probably can build on a little bit to the previous topic of around connectivity. So we're talking about connectivity, and people get a little bit nervous about connectivity, and then they fear what happens if it goes wrong. And I think that sort of translates a little bit to do with variable rate. So my first variable rate journey was buying an air seeder that was variable rate capable. And I was so paranoid about what happens if the system fails. Like, I know that if I just go on blanket rate, if I get 30 hectares for my tank, I know that it's gone out right. So I bought a ground drive air seeder because I thought, well, if all the electronics in the world go wrong, I could just still manually make it work. So a fear of it not working. But in hindsight, when have I ever manually rigged up the ground drive? Never. So it's always worked. So don't fear the unknown, I guess. Mm-hmm.
Yeah, good point, James. Bindi, would you have any comment on top of that?
I think it's potentially like the computer aspect, or being concerned about not being able to do it right, or what if you get it wrong. But I think certainly using the computer technology is one limitation, and then reliability of getting it work. So when I look at our clients that we've been doing variable rate for 10 or more years, they're ones that did early trials and know that the concept works, but they can't use a computer and they can't even look at their My John Deere to see where machine is. They'll often ring me to do that. So they're quite happy to use the tech, but get someone to help them. And I think for a lot of people, they're a little bit not convinced that investing time in learning how to use the technology is actually potentially worth it as well. So, yeah.
Yep. Thank you, Bindi. Actually, Bindi, we'll go back to you with this question. It's about software platforms. What software platforms are being used to manage multiple layers of data for arriving at VRT prescriptions?
Yeah, it's a really good question. I would love a software platform that can do everything, but I think it's a unicorn at the moment. So I operate between multiple different platforms, but for using multiple layers of data and good analysis and those sort of things, I tend to use ones like PCT Ag Cloud or SMS Ag Leader, because they have more analytics and things that you can do in them to create the prescriptions, whereas some of the other software platforms like the machinery platforms are more simple, which you can easily get a prescription from yield. It's just making sure that yield is actually giving you the prescription that you want to manage the issue. So yeah, the two main ones that I use are that PCT and SMS Ag Leader. I know other consultants will use the Trimble one as well, or what used to be FarmWorks, which is like the equivalent of what SMS was. And I like SMS because it's on the desktop. So when we lose connectivity or whatever, we can still do work and get the jobs done. But the benefit of the new web-based platforms is you get the latest updates straight away, which is very cool, except sometimes you can go in to do something and the button's moved or disappeared. So that can take a bit to get used to.
Mm-hmm. Thanks, Bindi. James, Tom, do you have anything further to add there?
Yeah, I'd say probably just with the choosing the platform for what you want. I've been the same. I use PCT for a variable rate, but I find our boundary management and actually drawing boundaries and being able to edit from recording SMS allows us to zoom a lot closer in, add a lot more points, and for obstacles, like we've got lakes and stuff, you can actually extend guidance lines the whole way across the paddock. So we sort of line up the edge of the cedar on a lot of bits of bush and actually make sure that we're not getting caught with half runs if we can avoid it, and straightening bits to match tram lines. So little features like that we've sort of found a lot better with SMS than John Deere for boundary management. I think it's all about choosing what gives you the best flexibility and working with your advisor. There's no point having a software that no one else uses for VRT or anything, and you can't actually get any help from anyone with the map creation.
Yep. Thank you. James?
Yeah, I'm a bit of a FarmWorks man. Very dinosaur of a program. It's it's pretty clunky, but I just find the amount of power and things like Tom was saying, you can do a lot of things that you can't do with some of the modern things, but it's pretty frustrating when you make something and then you've got to get it out into John Deere or get it out into FieldView to send it to a machine, to send it to a machine.
Good, thank you for that. So Tom, you're already using fully automated machinery on farm, and James, it would be fair to say that you are you're on the way there. So James, if you were talking to another farmer who was already applying variable rate methods and had their boundaries mapped and decent connectivity, what would be the biggest piece of advice or consideration you would share in terms of what to do next in your experience?
I think one little thing that trips people up is like correction. So I'm a multicoloured person. I don't like sticking to one manufacturer if they don't make the best of everything. So I like to buy the best machine to do the job. So sometimes that means I have multi auto steers or different things. So one thing we've done with we've got our own John Deere base station, but we use a Trimble correction on some of our CNH gear. So we surveyed them. We surveyed our John Deere system with the Trimble beacon. So therefore they're exactly the same. So whether or not you get a drone in to scan weeds to spot spray them, you really need to know that they're exactly where they are. So just having all your correction on all your auto steers all the same is pretty handy.
Mm-hmm. Yep. And if I could just switch to Bindi there to ask if there's anything you would add there, Bindi, in terms of that sort of transition phase, that what's important.
No, I actually think that connectivity is a real one, and it's one we've probably not had to worry about in the past. But as we've been able to now become a lot more accurate about where we place things because of section control, and we've got 2 centimetre guidance, like it does matter now when we're 20 or 50 centimetres out. So I think, understanding that correctional signals is very important when you're going forward.
Yep. Tom, do you have a comment there?
Yep. Just on the connectivity before I give a couple of tips. I guess my view on it has been always like, if you can see the benefit of autonomy or variable rate or whatever, and your limiting factor is a Starlink, that's not that big a upfront crop. Like, doesn't cost that much really to get it all set up. Like, I don't think connectivity should be the barrier now with options like that. I actually think like the payback on it, if you can see a payback for your production, like the upfront cost of getting a Starlink Mini in your ute or setting your shed up with a Starlink actually isn't probably where the break-even point of adopting some of this stuff is, personally. Yeah, a couple of my bits that I've noticed back with what Bindi said earlier about your fields and your naming, that's absolutely key. We use a TopCon screen, and they're the only ones with a slightly different file structure, which makes it a massive pain when trying to do variable rate maps or changing shape files. But one of my tips for mapping, I wouldn't sort of move into variable rate or autonomy or anything without making sure my map is, like, my shape file for the boundary is absolutely spot on. So we did, but we're up to 4 remaps of the farm now, and in some spots 5, just with we've learned a few bits, and then we've changed to John Deere and remapped that the same. And then now with the SwarmBot, just a few extra obstacles that we've had to map. But we put our receiver over the back axle. What we've found with boundary steering equipment and the autonomy is that if you have it on your bull bar or the roof, like a lot of other setups, and we did it for the first 2 until we learnt this tip, is that the curve actually steers quite sharp. When it's over your back wheel, it's actually quite a nice smooth curve. So when you're in a sprayer at 25 Ks, it actually draws a curve quite smoothly. When it is a sharp turn, it sort of nearly throws you out the side window at some points, or in an Arctic tractor. And having a set buffer, we were doing it for slashing around fence lines, so we're 1.3 meters off. But now we've moved into autonomy. That's a 1.5 meter buffer. So it's allowed us to just bring the map, shrink it by 200 mils, and we're perfect. And I know every obstacle's been mapped at that exact distance. So otherwise we would have had to remap the farm again for a SwarmBot if we couldn't be confident about that. So yeah, we put the conduit off the bull bar at exactly 1.3 meters, and every time we're recording a point, it's nearly touching the fence. So yeah, that's probably my biggest bit of advice, I'd say.
Thanks, Tom, for sharing that really practical advice there, or a tip. Going to audience questions, Mark has asked, Sue, this is one for you, I think. What options other than Starlink, Telstra and Optus do we have for connectivity?
Well, there are lots of options for all sorts of farm environments. In addition to those suggested there, there's signal extension via comms extends. There's other LEO satellite options. There's private LTE tower networks.
Okay, thank you. Thank you. I hope that's answered that question, Mark. Mark, you've also put in a question or a comment about, given we have self-driving Teslas and automated mining equipment, what do you think the barriers are to agriculture having larger tractor units? Are we slow on the uptake? Would someone like to make a comment there? What's the barrier? What do you think?
Well, personally for us, there's a few bits where, like, we have a lot of lakes, and so we've got an 18-metre swarm bot, but our boom's 36 metres, where you're sort of lifting over your fences or you're folding up with a wider boom, whereas with our 18, we can fit through a lot of gaps. So there's probably a lot of that part of it, and a lot of the sensor and obstacle detection. I know with the robot, any wider than about 24, they're battling to, like, it's harder to see as wide, or in our experience, that's sort of what we've been told of why it's not wider. Yeah, that's, I guess, for us, we still probably like the idea of two 18-metre machines, that we don't have to go out and manually spray between some of these obstacles that a wider one wouldn't be able to get through.
Yep. Yeah, good point. Anyone else? Bindi, would you have a comment? No. Anyone else like to have a comment there about barriers?
I think one barrier, or one reason the other things have been developed so well, is like cars, especially have got, before automation cars happened, we had cars running around with cameras and just collecting bulk data, so that there's a lot of machine learning and also a lot of learning happening in the background. And mining is just probably a large wallet to be able to just spend, and probably those automated mining equipments are very much the same thing all the time, and farming is like a factory outside, so it's an uncontrolled environment. But yeah, I don't think there's any excuse not to make this happen faster, because it's what's coming. And
Yep. Thanks, James. So we will take this probably our last question, if we could get perhaps a quick response from John. Thoughts on VR application of pre-emergent herbicides to reduce crop impact risk or optimise weed management? Any comments on that from Bindi? You're nodding your head. I'll go to you.
I feel like that was a setup, that one. I think there is real opportunities for variable rate application of pre-emergent herbicides. And there is actually a Grain Automate GRDC funded project on this topic that's being led by Syngenta. And we're actually working over here as one of the partners, I guess, working on it over here. And particularly the main concept we're looking at over here is where we have sand versus gravels, and the gravels have higher clay content and often are more weedy. So the opportunity is to actually use a more higher value pre-emergent herbicide that on the gravel to get a better weed kill that would actually damage the crop on the sand. So the concept is correct, and I think we can zone for the soil types. It's the technology, I think, is probably a little bit challenging, and the Syngenta project's working on a direct injection technology, and they've built a little sprayer to demo it and see if we can get it to work. And I know it has worked, but there's a few things that are challenging in terms of that chevron effect and building, having to have multiple sections, and also the products not going through, staying in solution. So because it sits in a little tank that gets directly injected into the boom. But I think sprayers have also, technology's advanced, and we can now get sprayers that have two big tanks and dual lines. So that's a potential opportunity that you could actually have them already pre-mixed and have your prescription that would run one tank and put that higher cost, high rate of a herbicide or a different herbicide chemistry on those, say, gravel soils compared to the sands. So yeah, I think there's a lot. We haven't done lots in spraying technology for variable rate, but I think it will be a really big one if we can nail it, because it's easy to see the benefit, like the weed's either dead or it's not, or it's there. Whereas often the fertiliser aspect we don't see so well, or it's put under the ground. It's not often as visual.
Great, thanks so much, Bindi, for that answer on that question. Unfortunately, we will have to leave the discussion there. Thanks for your time to Bindi, to Sue, James and Tom, we really appreciate your time today. So that brings us to the end of today's SPA event. Before we sign off, I would like to again thank the presenters, Bindi, Sue, James and Tom. It's been a pleasure to have them with us today. Thank you, our audience, for watching and participating today. Your feedback is appreciated, and you will see a short survey appearing on your screen that will remain open after the close of the event. Wishing you all the best for the 2025 season, and until next time, it is goodbye from all of us.